A, B, C will be done on all the parts, so that the progressively the part will be getting the final shape. And if you want to change over the sequence from A, C, B, it is not possible, because all these machines will be integrated. The meaning of integration is very simple. In between the lines, in between the two machines here, now I say the machine will be workstation. Okay, the machine will be called as workstation, and the number of operations which I am going to do will be work centers. Again, I repeated many times. I am repeating many times. On a lathe, I am going to do two operations. That means the lathe is a workstation, and two operations I do will be work centers. And if there are 3 or 4 machines integrated together, the meaning of integration is very simple. I am going to provide a conveyor in between them, and somewhere if it is required, manually the part will be transferred. That will be called as partial automation. That means partly it will be manual and partly it will be just a minute. I'm sorry. The part will be processed on the transfer lines. That means the conveyors, and partly some of them will be handled manually, and that is called as partial automation. In some other cases, when for example the part has to move from A machine to the B machine, A processing will be done, and next the B processing will be done, and C processing will be done. That may be very simple, a plain turning and a threading and knurling. Very simple example I am going to take. First I am going to do the plain turning, and the part will be sent to the next machine, and therein I am going to do the threading, and again the part will be sent to the next machine. There the knurling will be done. Okay, all these parts will be transferred automatically from one machine to the other machine by means of some of the work holding devices and conveyors and appenders and dependers. Appenders and dependers are the orienters. Okay, the orientation of the part. Sometimes the part has to be held horizontally, sometimes the part has to be held vertically, sometimes the part has to be held in very similar different fashion, like at different orientation. So that time the orienters will be used. Now please remember here, A machine, B machine, C machine. That means the way A workstation and B workstation and C workstation may not have the same cycle time. The cycle time is totally, I already told, the cycle time will be it will be consisting of the non-operation time, operation time, work holding, handling time, work holding time, and all these maintenance, everything will be included to complete one cycle. So definitely the threading and the plain turning will not take the same amount of time. So once after the part is processed in one machine, then it has to go to the next machine. In between them, since the A, B, C different workstations may not have the same cycle time, then the part which is processed in A machine has to be sent to the next machine. Very simple example, you say the A machine is producing at the rate of 1 part per minute. The second machine is producing the part at the rate of 1.5 minutes. That means the first machine is producing at the faster rate, the second machine is producing at slow rate. So that what happens, the work will be jammed in between A and B station. You can see that because the production rate of the A machine will be more than the production rate of B machine. So in such cases, what we'll do is we'll be using a buffer storage. Buffer storage unit is one. It will be storing the extra material which is coming from the A workstation, and it will be stored in the buffer storage. Why this buffer storage is required? Whenever any of the machines will be coming from for the maintenance, you see all these machines will be integrated together. For example, if there are 10 workstations, the 10 workstations will be integrated together. if any of the machine is come for the maintenance, okay, once the machine is come for the maintenance, the whole process will be jammed. To avoid this jamming of these processing in between the workstations, a storage unit will be used. This storage unit will be storing the work which is processed from the previous workstation, so that whenever there is a problem in one machine, for example, there is a problem in A machine. Now B machine required the part. Since the A machine is under maintenance, I cannot able to supply the part to the B. So that time the buffer storage unit, which is provided already in between A and B, from there the material will be taken and it will be processed. Okay, and here one term will come across, I have not written here, starving of station and blocking of station. Please make a note. Sometimes, many times they'll be asking a short notes of starving of station and blocking of station. Simple here, I'll take one example. You can able to see, I think. For example, you say this is the station 1, this is station 2, this is station 3. Now the station 1 is producing the part, it is sending to this machine. But unfortunately, this particular machine is come for the maintenance. What happens? It want to send the material to the next, but there is a conveyor in between this, so it will be blocking the path. I think, Varun, you are understanding me?
Yes, sir.
Yeah, it will be blocking this path because it is producing this particular second station is under maintenance. Now it will be finding the blocking, so that is called blocking of station. The blocking of station is from station 1 to 2. The blocking of station 1 to 2 is blocking, but here this particular station 3 is required the material, it cannot able to supply because of it is stopped. So now here we can say the starving of station. Even the part is required at this particular junction, it could not able to supply the material because it has come for the maintenance. So in a particular path, whenever a particular station has come for any maintenance, the whole line will be facing the jamming of station, that is blocking of station and starving of station. Blocking of station is the particular station will be blocked. See, the station 1 is facing the blocking of station because this machine has come for the maintenance and this machine is producing, but what happens on the conveyor, whole part is filled. It cannot move front because this particular, unless otherwise this particular station is maintained or repaired, the part will not go next. So that this particular station 1 will be facing the blocking of station. And the station 3 is facing a starving because it is starving for the material. Even though it is correct, it is ready, there is no maintenance. In this particular station 2, there is a maintenance, it cannot supply the material to the next, so that it is called a starving of station. Please make a note, all of you, write a short notes on starving of station and blocking of station. Please make a note. Are you making a note of it?
Yes, sir.
Yes, sir. Yes, sir.
Starving of station and blocking of station. Whenever I come to this particular topic in this only, I'll explain you. Okay. Now, in this particular the automated production line, as the name indicates, the production will be taking automatically. The materials will be transferred from one station to the other station and next one to the next station. Very simple example is I'm going to integrate milling machine, drilling machine and cutting machines for a definite operations on particular part. I'm not going to do any changes in the sequence. And other example is that robotic spot welding. Many of you have seen in the Discovery TV and so many other automated devices, in especially the automobile industries. Whole part, the body will be moving from one station to the other station. A specific spot welding will be done by the robots, and again it will go to the next robot. A specific spot will be done. Like that, a definite work will be assigned to particular robot, and the part will be moving from on the conveyor from one station to the other station. Here the station will be robots. The robot will be completing the spot welding process. In some of the processing industries like the material coating, the painting and material coating, and some other industries like in the galvanizing will be done on the part. There also we can go for the automation. Okay, electroplating, these are the examples. So I hope you understood. Automated production lines are those the workstations will be integrated by means of a definite work transfer unit and the conveyors. And in between the two workstations, the conveyor will be transferring the material from one station to the other station. And the conveyor movement will be decided based on the workstation, which will be consuming maximum amount of time for the operation. Okay, once a particular operation is done, then it will go to the next station, like that. Okay, now the automated production line examples, it is a fixed automation. Since the machine configurations, the conveyors and the appenders, the down enders and the work holding devices, all these will be fixed for a particular part. So it is a simple example of fixed automation. It is generally difficult to alter the sequence and content of processing operations once the line is built. As I told you, in the fixed automation, everything, all the sequences and operations will be definitely defined in the beginning only before you go for the automation. In fact, if you want to do any changes with the system, it is not possible because it is hard automated. I mean, it is a fixed automated. And their applications provide many other the demands, like high demand. Wherever we require a high production quantity, the quantity of production will be very high, and throughout the service of its life, a particular industry will be taking the same quality and same type of product. So that time, whenever the high demand is required, that time we are going to use the automated production lines. In other way, we can say these are the fixed automation systems, and these are suitable for the product design, and they are suitable for a stable product design. They frequently are not going to do any changes with the product. Okay, and therein we can able to accommodate the automated production lines and longer product life. And several, at least I am not going to change the production style. At least of several years, and most of the cases we can provide the fixed automation, and we can, wherever we require to have multiple operations. The multiple operations in the sense performing the operations on a product, definitely we are not going to do any changes. So that is multiple operation. Okay, so please remember the advantages of going for the automated production line is that wherever it requires high demand and where a stable product is required, and we require higher qualities and high quantities and longer product life. That means the product will be for the several years. The product style, we are not going to do changes with the several years. So that time we are going to have the fixed automation, in other words, automated production lines. Okay, and when the application satisfy these conditions, then what are the advantages of using these automated flow lines? It is very generalistic, very general, and generally you can say it consumes a low amount of labors. Labor requirement will be very less, because in between the two production lines, in between the two machines, please don't say here machine, in between the two workstations, a definite conveyor